This is exercise 8D on using recurrence relation to generate and analyze arithmetic sequence on page 367 of your textbook. Now, over the last few lessons, we've been looking at the idea of all these arithmetic sequences, how to continue the sequence, and also how to find a formula or write down the formula in order to find a specific term. Now, of course, if the question says to find the first 5 terms, including 1, 2, 3, 4, then the formula isn't very helpful because it only is there to help you find one specific term. Okay? But we're going to be writing this in a recurrence relation form. Basically, it's just another way of writing this kind of sequence. The reason why you need to learn this is not only do you need to be able to write it out in recurrence relation form, a lot of the time assessments will give the the arithmetic sequence to you in recurrence relation form, and you need to be able to interpret it, okay? Which is why it's important for you guys to understand this part. It's just expressing a rule in a different way. So the recurrence relation here, I've got written up here, this is the most important part right here. T1 equals to A, Tn plus 1 equals to Tn plus D. All that's saying is T1 equals to A, you guys know what that means? The first term is whatever the first term is, you guys would substitute that in. So if the first term is 6, you would write T1 equals to 6. Comma, and this part is the most important aspect here. It's saying the next term, because Tn plus 1 is just the next term, right? If n was 5, then Tn plus 1 will be T6. So therefore, it would be the next term. So the next term is the term we were talking about plus D. So the term, the previous term, plus the common difference. Now, the common difference could be a negative value, which means it's going down. That's fine. But it means that we're adding whatever that value of D is. Sounds a bit complex. We'll get into the examples pretty quickly. We can use this to generate the arithmetic sequence with the first term and a common difference. The nth term of a sequence generated by this recurrence relation is the same as we've done before. Okay? So really just focusing on how we're writing out that type of sequence. I'm going to jump straight into this example right here. Generate and graph the first 5 terms of the sequence defined by the recurrence relation. Now, based off this recurrence relation, you're going to hear that word a lot. What is the first term? What's T1? 24, good. Now, according to the rule, it's saying that with each new term, we're minusing 2. That's what it's saying. The common difference will be negative 2, but we're minusing 2 each new term. So, what's the next term? 22. Good. And then? 20. Awesome. You guys get the pattern, don't you? And we're going down by 2 each time, and I'm just going to signify that it continues using my ellipses. So 24, 22, 20, 18, and 16, going down by 2. I've created the sequence based off the recurrence relation. Now all it's asking me to do is graph the first 5 terms. So I could go ahead and create a table. I'm going to forego that step now, and I'm going to go straight into graphing it. So I'm going to draw my 2 axes first. You guys see that up the back? Yep, awesome. I'm going to go ahead and write T0, T1, T2, T3, T4, and finally T5. Okay. Oh, sorry, my apologies. That should be N, not the T. My apologies, should be N. So N equals to 0, 1, 2, 3, 4, 5. Okay. And on this end, it's Tn. There we go. So, of course, our first term is 24. That's the highest one. I'm going to go ahead and put that up here, 25. So 24, 22, 20, 18, 16, etc. Of course, it should be in a straight line because it's an arithmetic sequence. Okay. So the idea is we're creating a sequence based on the recurrence relation. Now the second part of the question is asking us to use a rule to calculate the value of the 33rd term. Of course, if you're going to do this continually until you get to 33, it's a little bit annoying. So we're going to use the rule, but we have to identify the 3 variables. Okay. So what was A again?
24.
Good. A was 24. What was D? Good. Why is it negative 2? Going down. Good. And what is the value of N?
33.
Why is it 33?
Because we're getting 33rd.
Good. Because we're looking for the 33rd term. In other words, we're looking for T33. Okay? There's a lot of noise outside, isn't there? Okay. And from there, we use the rule. So I'm going to go ahead and write T33 equals to A, which is 24, plus, good, bracket n, which is 33, minus 1, times by negative 2, good. So you're going to take out your calculator, put that in. I'm going to go ahead and do that here. That's 24 plus bracket 33 minus 1 times by negative 2 gives me negative 4. Now, does that sound about right? Yeah. Sorry, negative 40, my apologies. Does that sound about right?
Yeah.
It does, good, because it's going down by 2. It's not going to stop at 0, so negative 40 sounds good. Awesome, any questions about that? Okay.